All right, welcome to integration piecewise functions. We have this piecewise function over here, and again, that just means that there are literally separate pieces to the function. So this piece, this cubic function, is only valid when x is less than -2. Between the values of -2 and pi, we have a line, and from pi on, we have a sine curve. So the first thing I'm going to do is graph this thing, and then I'm going to look at where it's continuous. I'm going to answer letter C, and then I'm going to switch pages to answer D and E because they get a little bit more complicated. So bear with me on this as I try to graph this thing to the best of my abilities with this little sketch pad. So I'm going to graph a very straight x and y axis. I'm going to do this part first. Now, what we should know about x cubed is, in general, an x cubed function looks like this, but with a negative out in front, an x cubed function generally is going to go like this. Back from your Algebra 2 power function unit. So what I'm going to do is I'm going to plug in this boundary point, because this is the really important point, because I need that to be kind of my starting point in my graph. So I'm going to graph a bit more, and then I'm going to use the eraser for a second so you can kind of see what's going on. So when I put in -2 into here, I would get negative times -2 cubed, and -2 cubed is -8, so that would give me a negative times a -8, which is a +8. So way up here at 8, and I'm not going to make the most accurate graph, so that would be an 8. At -2, I'd have a dot up there. And again, the x cubed graph would normally then pass through here, would also pass through -1, 1, and 1, -1, and at 2 it would be way down here at 8. So the actual x cubed graph would look like this, if I can actually manage to make this smooth. Perfect. Really quite perfect. See how I made that perfect? But we only care about this graph when x is less than -2. So I get to pull up my eraser, and I don't care about any of this part of that graph, because this is when x is bigger than -2. So I'm going to very carefully try to erase that without erasing my axis. All right, and I'm going to switch colors on you so you can see what's happening. This part I will do in red. This is just an equation of a line. Again, these are my two boundary points, so they're the ones that matter. I'm just going to graph a line between these 2 points. So I'm going to plug in -2 into that line, because that's going to be where it starts. I'm going to erase all this garbage up here because we don't need that anymore. I'm going to put -2 in here, which would give me -3 times -2 plus 2, which is 6 plus 2, which is 8. Hallelujah, because at -2 I end up right here. That's going to help me answer this question in a minute. So I'm going to start there, and I'm going to end when I plug in a pi, which, let's be honest, that's pretty annoying. So again, I'm going to come up here and I'm going to erase this stuff because I don't need that. That's just my work, and I don't have a lot of space, so I'm going to get rid of it. I'm going to put pi in here, which means I would have -3 pi, excuse me, plus 2, which, if I just assume this is 3, it's 3.14, etc., this would be like -9 plus 2, which is about -7. So when I'm at pi, which again, if I go 1, 2, 3, pi is somewhere around here, I would be at about -7. So again, I'm not going to make the most perfect graph here, but at pi it'd be about -7. And this is going to be a direct line. Now, to make sure everything's spot on, I know from this line that my y-intercept is 2, so I have to actually cross at 2. And so my line should come straight through here like this. Boom, that should be a straight line. I apologize, it's not perfectly straight, but it's pretty close. So now I'm going to come in here, and I'm going to erase all this garbage again, and we're going to switch colors, because now I need to go to green, and I'm going to now deal with sine, starting at pi and moving on. So I just need to know, what the heck is the sine of pi? Well, if I look at this guy here, that's 0, that's pi over 2. Here's pi right here. And I'm going to draw this again in a minute, and the coordinates of that are -1, 0, and sine is the y coordinate, so the sine of pi is 0, so that's where the sine of pi starts, and it is going to go to 2 pi, and it is going to go beyond. But if you remember, sine actually goes like this, So I am really interested in this part coming down here, and it's going to keep going. It's going to keep going forever. This here should be -1. There's no amplitude change, so this dip here should be a very smooth curve. There should be no, I don't know why I keep doing that. There should be no messing with that. All right, there we go. Now what I want to point out in this fantastic color of blue is that there is what I would call right here, these are supposed to be dots, that is what I would call a gap, which again is then going to help me answer this question, because if I'm asking when this function is continuous, that's when I can run a pen or a pencil over this smoothly without lifting it up. So assuming this keeps going, like the cubic function, I'd be fine here. There's no gap or hole here. I go right through it all the way down, boom, all of a sudden I have a problem. I'd have to lift this thing up and then restart it here to get the sine curve. So this thing is continuous. So the answer to B would be it's continuous from -infinity until I get to pi, does not include pi, and then after pi, the rest of the way, the sine function is continuous. So official notation, I'll put a U in there for union. So that's indicating that it's not continuous at pi. There's a discontinuity at pi. All right, now I'm finally getting to what I was hoping to do all along, which is this question right here. Integrating from from -3 to 0. This is not asking me to find the area. So if I was asking to find the area, this area would all be positive. This area is negative, but if I was asked to find the actual area, I would have to turn these into positives by doing 0 minus the function. That's what we've been working on. But this just says straight up integrate. But I have to be careful because notice that from -3 to 0, I've got an issue right here at -2. So this thing is going to become two pieces. That's why it's called piecewise. So I'm going to go from -3 until my first issue, which happens at -2. So from -3, which is right here, to -2, I'm going to integrate just that function, because after -2, this guy doesn't matter. So I'm going to integrate -x cubed dx plus, switching colors just so we see, I have to also integrate a separate piece. And that is because from -2 to 0, which would be right here, I would be integrating this function, because that's the function that exists from -2 to 0. So -2 to 0, I'm integrating -3x plus 2, -3x plus 2 dx. And now I have to actually do some integration. So I'm going to come over here. This thing right here would integrate to -x to the 4th over 4, and I have to evaluate that between -3 and -2, plus if I integrate this guy right here, it's going to be -3x squared over 2 plus 2x, and I have to evaluate that between -2 and 0. So I just kind of keep cruising here. If I put -2 in this, I'm going to get -2 to the 4th is 16, so I get -16 over 4. This 4 power makes that actually become a positive, but there's still a negative on front. Minus, if I put a -3 in here, -3 to the 4th is 81, so I'm going to have -81 fourths. And before I even move on, I'm just going to change that to a positive. Plus, that's just that plus sign brought down. I put in 0 here, it's just going to be 0 and 0, so I'm not going to write too much there. 0 minus, and when I put in -2 here, it's going to be -2 squared is 4. 4 times -3 is -6, divided by 2 is, -2 squared is 4 times -3 is -12, divided by 2 is -6. And if I put in a -2 here, I'm going to get plus a -4. And I can finish this very quickly because these two are both in terms of fourths, so I'm going to leave them that way. 81 and a -16 fourths should give me 65 fourths. And this in here is -10, but this negative out here means I'm actually adding 10. And 10 is the same as 40 fourths. So this answer is 105 fourths. That is the answer for the first part. Do not forget it. And this video is taking a very long time, so it may actually take longer than 15 minutes. Now I'm going to do this part, which is -2 to 0. -2 to 0 Notice this guy starts at -2, so for this one I'm integrating from -2 to 0, and I'm just integrating -3x plus 2 dx. Well, guess what? We just did that. That's exactly what we did right here, and we had an answer right there, and that answer was what we got from doing this, and that answer is right here. And so that answer to the next one is just 10. I'm stealing an answer. If you need to slow down and go back and look at that, you can, but I'm running out of time, so I'm going to move on. And apparently I don't. Oh, there it is. All right, now we're going to do this guy right here. So again, this is going to be in pieces, so I'm integrating from -3 to -2, and that's just this part right here. Again, we've already done that, so I'm going to steal that answer in a minute. Plus, I'm now going to integrate from -2, which is where this middle function starts, all the way up to pi. Now that part I'm going to have to do a little bit of work on. Notice that 5 pi over 4 is bigger than pi, so I'm going to have to go integrate -3x plus 2, and then I also have to add from pi up to where I'm ending, my end bound, which is 5 pi over 4, and I'm going to integrate sine x. So I'm going to steal my original answer from this, because I already did this back here on letter C, and that part I believe was 65/4. Go back and check my work. Here I have to integrate, which I've already done, so I'm going to integrate this. It's still -3x squared over 2 plus 2x, and I'm going to evaluate that from -2 to pi. I have to integrate sine. If I integrate sine, it actually equals negative cosine x, and I have to evaluate that between pi and 5 pi over 4. So if I come down here, I've got 65 over 4, plus if I put pi in here, I have this weird -3 pi squared over 2 plus 2 pi. If I put -2 in here, again, that's going to be a minus. And we actually already know what this is going to equal because we've done it. This, plugging a -2 in here gets me -10. We did that twice now, really. And then over here I've got, putting in negative cosine of 5 pi over 4 minus negative cosine of pi. And I'm going to change a couple things. First off, I'm going to immediately change that to a plus. I'm going to change that to a plus. And so I can already make my answer a little bit better here, because this 10 plus this 65/4, we already know this was 40/4 from before. So these two guys are already at 105 over 4. This, don't know, -3 pi squared over 2. This plus 2 pi. And now I've got my trigs. Well, cosine of pi, we've already sort of looked at this. Cosine of pi is, here's pi. Those coordinates are -1, 0. So cosine of pi is -1. So really what I'm going to do over here is if I take 1 away from, oops, I'll just actually do it, minus 1. And then 5 pi over 4 is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. It's a fourth. This equals negative rad 2 over 2. You have to know your trigs for that. That negative is right here. This is a negative for cosine, so that again becomes plus. So as I run out of time here, this -1 is really minus 4/4. So these guys right here would become 101 over 4 minus 3 pi squared over 2 plus 2 pi. Again, those two I combined together. And this is plus rad 2 over 2. And then if I go to my calculator, because quite honestly I don't know any of that stuff, type in, I can try to type in 101 divided by 4 minus 3 pi squared divided by 2 plus 2 pi plus rad 2, and I gotta divide that by 2, and I type all of that in and I get an answer of, you see it, I see it, it's right there, 17, oops, I've lost my marker, 17.4 something, but my calculator went away. That's what it was. A lot of work, perfect timing, pause it, slow motion it, go back and watch it. That's the end. Hope you enjoyed it. Goodbye.